Hello student. Last time we have seen law of triangle for vector addition of two vectors. Now today we are going to learn another method for the vector addition of two vectors, that is the law of triangle of vector, law of triangle, law of parallelogram of vector addition, law of parallelogram, law of parallelogram, parallelogram of vector addition of two vectors. Two vectors, two vectors. Consider we have parallelogram A, B, C, D. Consider we have parallelogram A, B, C, D, A, B, C, D. And the diagonal start from point A is the AC. In this parallelogram A, B, C, D, adjacent sides AB and AD are representing two vectors P bar and Q bar. P bar and Q bar, and their resultant represents by AC. Resultant R bar is represented in magnitude and direction by the diagonal AC bar. What is the statement of this law of parallelogram? The two vectors are represented in magnitude and direction by two adjacent sides of the parallelogram. The resultant is represented in magnitude and direction by its diagonal drawn from their common point. What is the statement? Listen carefully. If two vectors are represented in magnitude and direction by two adjacent sides of parallelogram, take adjacent sides of parallelogram, and then the resultant represented in magnitude and direction by its diagonal drawn from their common point. Statement if two vectors if two vectors are represented in magnitude and direction by the adjacent sides of parallelogram and their resultant is represented in magnitude and direction by the diagonal drawn from their common point. Suppose ABCD. Suppose ABCD is the parallelogram in which in which adjacent sides AB bar and AD bar are represented. The magnitude and direction of P bar and Q bar on the diagonal AC bar represented in magnitude and magnitude direction the represent the magnitude and direction of their resultant R bar. Therefore, AC bar is equal to AB bar plus AD bar, and finally we have the relation R bar is equal to P bar plus Q bar. Once again told you that. Consider we have parallelogram ABCD in which adjacent sides AB bar and AD bar represents the magnitude and direction of vector P bar and Q bar, and the diagonal AC bar represents the magnitude and direction of the resultant R bar, and therefore we get AC bar is equal to AB bar plus AD bar, and that is R bar is equal to P bar and Q bar. And this is the explanation about the law of parallelogram of two vectors. Now, we are going to determine the magnitude and direction of resultant vector R bar, magnitude and direction of R bar in term of magnitude and direction of P bar and Q bar. Magnitude and direction of R bar in term of magnitude and direction of P bar and Q bar. Magnitude and direction of P bar and Q bar. Determination of. Question can be asked, determine the magnitude and direction of. Question can be asked, determine the magnitude and direction of resultant vector R bar in term of P bar and Q bar. Therefore, the determination of magnitude and direction of resultant R bar in term of magnitude and direction of P bar and Q bar in a parallelogram. Means here we are going to determine magnitude and direction of R bar in term of P bar and Q bar. Suppose ABCD is the parallelogram. Parallelogram. Let adjacent sides AB bar and AD bar represent the magnitude and direction of P bar and Q bar. Diagonal AC bar represent the magnitude and direction of R bar. Let theta be the angle between AD and AB. AB and AD. Let alpha be the angle between AC and AB. Draw 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 normal CE to AB produced. CE to AB produced. Therefore, this also theta. This angle also theta. Now inner triangle AEC, inner triangle AEC, AC square is equal to AE square plus EC square. Therefore, AC square is equal to, how to write AE? AE means AB plus B. AB plus BE square plus EC square. Solve this bracket. We get AB square plus twice AB BE plus BE square plus EC square plus EC square. This equation number 1. This equation number 1. Then inner triangle BEC BEC BC square is equal to BE square plus EC square cos theta is equal to BE upon BC. BE upon BC, and therefore BE is equal to BC cos theta and sin theta is equal EC upon BC. Sin theta is equal to EC upon BC. Therefore, EC is equal to BC sin theta. BC sin theta. In a triangle BEC, BC square is equal to BE square plus EC square. BC square is equal to what? BE square plus EC square. Substituting the value of BE and BE square plus EC square in equation 1. Substituting the value of BE square plus EC square, and BE is equal to BC cos theta in equation 1. Substituting the value of BE and BE square plus EC square in equation 1, we get AC square is equal to AB square plus twice AB into B means what? BC cos theta. BC cos theta plus BC square. This equation number 2. Put AC is equal to R, AB is equal to P, BC is equal to AD is equal to Q, and BC is equal to AD is equal to Q. Therefore, we get R square is equal to P square plus twice PQ cos theta plus Q square. Finally, R square is equal to P square plus Q square plus twice PQ cos theta. Cos theta, and therefore R is equal to under root P square plus Q square plus twice PQ cos theta. This is the magnitude of resultant vector R. Listen carefully. Consider in a parallelogram ABCD in which P side adjacent side AB and AD represent the magnitude direction of P bar and Q bar. Diagonal AC bar represent the magnitude direction of the resultant R bar. Theta is the angle between P and Q. Alpha is the angle between side AB and AC. Now in a draw C, a normal C to AB produced. This normal C to AB produced, and therefore in a triangle AEC, AC square is equal to AE square plus EC square. Therefore AC, but AE is equal to what? AB plus B. AB AE is equal to AB plus B. Therefore, here we get AC square is equal to AB plus B per bracket square plus EC square. Solve this bracket. Just like A plus B whole square is equal to what? A square plus B square plus twice AB. Similar way here, AB plus B whole bracket square is equal to AB square plus twice AB into BE plus BE square plus EC square. Then in a triangle BEC, BC square is equal to BE square plus EC square. Cos theta is equal to BE upon BC, and therefore BE is equal to BC cos theta. And finally, sin theta is equal to EC upon BC. Therefore, EC is equal to BC sin theta. EC is equal to BC sin theta. Substituting the value of B and BE square plus E square in this equation 1, therefore we get AC square is equal to AB square plus twice AB BC cos theta plus BC square. Put AC is equal to R, that is the magnitude of resultant. AB is equal to P, magnitude of vector P bar. BC is equal to AD is equal to Q, magnitude of vector Q, and therefore we get R square is equal to P square plus twice PQ cos theta plus Q square. R square is equal to P square plus Q square plus twice PQ cos theta, and finally R is equal to under root P square plus Q square plus twice PQ cos theta. In this way, we determine the magnitude of resultant R bar in term of P and Q bar. Here we have two more cases. Here we have two more cases. Case number 1. Case 1. If theta is equal to 0, cos 0 is equal to 1, therefore R is equal to under root P square plus Q square plus twice PQ is equal to under root P plus Q whole square, and therefore we get R is equal to P plus Q. Case number 2. If theta is equal to 90, cos 90 is equal to 0, R is equal to under root P square plus Q square. And third case, third case case number 3. If theta is equal to 180 degree, cos 180 is equal to minus 1. Therefore, R is equal to under root P square plus Q square minus twice PQ is equal to under root P minus Q whole square. Therefore, finally we get R is equal to P minus Q. Let us determine direction of R bar in term of P bar and Q bar. Let us determine the direction of R bar in term of P bar and Q bar. Now, in a triangle AEC, tan alpha is equal to what? EC upon AE. Tan alpha is equal to what? EC upon AE. EC upon, how to write AE? AB plus B. AB plus BE. But EC is equal to BC sin theta is equal to Q sin theta, and BE is equal to BC cos theta is equal to P cos theta. And therefore, tan alpha is equal to Q sin theta upon here Q square, Q cos theta, P plus Q cos theta. Once again told you that EC is equal to what? BC sin theta means Q sin theta. B is equal to BC cos theta is equal to Q cos theta. And therefore, we get tan alpha is equal to Q sin theta upon P plus Q cos theta. And therefore, alpha is equal to tan inverse Q sin theta upon P plus Q cos theta. This equation gives the direction of resultant vector r bar in term of p bar and q bar. Once again told you that first if case number 1, if theta is equal to 0, cos 0 is equal to 1, r is equal to under root p square plus q square plus twice pq is equal to under root p plus q bracket whole square, and we get r is equal to p plus q. If theta is equal to 90, cos 90 is equal to 0, then we get r is equal to under root p square plus q square. Case number 3, if theta is equal to 180 degree, cos 180 is equal to minus 1, r is equal to under root p square plus q square minus 2pq is equal to under root p minus q whole bracket square. Finally, we get r is equal to p minus q. Let us determine the direction of r bar in term of p bar and q bar. Now, in a triangle AEC, tan alpha is equal to EC upon AE is equal to EC upon, how to write AE? AB plus B, but EC is equal to BC sin theta is equal to Q sin theta. BE is equal to BC cos theta is equal to Q cos theta. Tan alpha is equal to Q sin theta upon plus alpha represent the direction of resultant vector r bar, and therefore alpha is equal to what? Tan inverse q sin theta upon p plus q cos theta. In this way, we determine magnitude and direction of resultant vector r bar and r bar in term of p bar and q bar. The magnitude and direction of r bar in term of p bar and q bar. In term of magnitude, r is equal to what? Under root p square plus q square plus twice pq cos theta. And in direction, alpha is equal to tan inverse q sin theta upon p plus q cos theta. हे लेक्चर कसं वाटलं ते कॉमेंट बॉक्समध्ये सांगा मला. चांगलं वाटलं तर लाईक करून शेअर करा. थँक्यू.